Hi, I'm Mike of Nearly Enough Dice, and this is the Kerbal Space Program. And I'm just in my sandbox at the moment. So I was playing around with some engine designs and discovered something. Well, I don't think it's a huge discovery, but it's a bit weird. It's one of those things that doesn't look like it should work. Okay, simple probe. Deep in there, you can't really quite see it. Deep in the middle of there, there's a hex. And there's a communitron on top of it. So there's a hex as the probe body. I've got batteries on the outside of it, and panels on the outside of it. I probably wouldn't actually design it this way specifically. I'm doing this specifically so I've got something I can attach just rockets onto it. So in an actual thing, I would possibly move those batteries off to a different place. This is simply so I can attach things. And at the bottom there's a computer control which I've been using, and there's a Kerbal engineering system slapped on the side. And so engines, and I was basically just kind of playing with these big tanks, right? And so you can see down here, this is the Kerbal Engineer Redux telling you the stats about this particular rocket. So at the moment it's got no thrust to weight ratio because there's nothing attached to it. There's no delta V. So this is a big orange tank, and this has got a main cell. So this is the biggest engine I have at the minute. Even though I'm in my sandbox, I've actually, because I've used at one point I used a save from my sandbox in order to experiment with various things. And that has interestingly set my sandbox to be that stage, and it's kind of become in career mode, and I'm not quite, that's interesting. I'm probably going to have to either make a whole new sandbox game or something, but interestingly I'm limited to the same things I had in my career. But anyway, doesn't matter. Main cell, big engine, right? So I get massive great thrust to weight ratio, which is nice, and a delta V of 4,995, which is approximately enough to get me into orbit with some to spare. I think normally you say you get to orbit with about 4,500, but you add about 10% on top of that on the assumption that you are going to not do the most perfect flight. So this will get me into orbit. This will not get me to the moon. So same tank, only this time I've got a skipper. Now the thing is that my thrust to weight ratio has gone down an awful lot, and that's potentially a problem. There's a question about how quickly you're going to get off the landing pad. You've got to go through the soup of the lower atmosphere and all that kind of stuff. But much more delta V, largely because this is it's a much lighter engine. The engineering thing gives me this little pop-up on the middle mouse click, so you can see how much it costs. Mass is 3 tons, thrust is 650, ISP is 320 in atmosphere. Just very quickly compare that with these. So the mass is double the mass, but it's not got double. I think it's got more than double the thrust. It's got a lot of thrust, but the ISP is not good. But it's just massive. I mean, even with a big tank full, I mean the main cell, weighs a lot. So so that contributes to the lack of delta V, because you've only got so much fuel, and now you've got twice as much engine to heft up with that fuel. And I was just playing around because you can see that the way the main cell works, the skipper works, there's enough room on the bottom of this, and that's it, right? But you do have a lot of surface area on these tanks, a lot of area, and I was thinking, what else could you do? So, in the spirit of what else could I do, I put this together. Let's move things out of the way. So these are my boring conventional engines that do boring conventional things. And what this is I've just stuck a whole bunch of these 48.7S's on the bottom of it. And although my thrust to weight ratio is lower, my delta V is noticeably higher. It's not as big a difference. I mean, it's only 100 or so meters per second of delta V compared to the normal boring rocket, 6118 versus 6206. It's not a huge difference. But I just find that interesting. I have tested this. I have flown this thing to the moon. I have flown this very craft to the moon and had fuel left over, which I'm fairly convinced I would not be able to do with just a tank and a skipper. It's a little crazy. It's a bit of a bizarre kind of setup, because if I'll just put this out the way and just grab another one. Right, take that away. Because if you just grab the 48.7S, you can only place it in the middle, like that, right? That's the only place. You won't actually attach. As you can see, it's still transparent, so I'm not actually attaching it. So what I kind of did is just went to the structural menu, grabbed the cubic octagonal strut. I think that's what I went for. Yeah, I think that's it. I actually did it as a multiple of 8 in the end. Alright. And now that'll fit on that nicely. And if I just grab that again, I can put another ring of 8 in. And so as long as I'm selecting the octagonal strut, hitting Alt, holding down Alt and then clicking, I get a duplicate. I wonder what that would do. Actually, now I'm just going to take the number of copies, the radial symmetry down to 4. And now I've got 20 of those engines and a nice big delta V. And enough thrust. I mean, at 160, it's enough thrust to get to the moon, because I have in fact done this. I think that's just a little bit mad. Yeah, so yeah, it's only like 30 thrust compared to the Rockomax skipper, which I can't select because it's. Oh, I can put it on the thing itself. That probably won't break it. Yeah. Anyway, so I can compare. Looking at the stats. That's the poodle. We don't care about that. So 30 thrust, ISP, 300 in the atmosphere, but mass 0.1. I think that's the issue, because you go to the skipper, it's got 3 tons of mass. So I could put 30 of these things on and weigh the same as the skipper and get a whole bunch of thrust. So there you go. And I mean, I could do things. I could possibly do things like, if I was able to take away and still get into the atmosphere with that if I can still, if that's enough thrust. I'm just going to hit Control Z actually. If that's enough thrust, then I just added another 100 delta V to my craft. That shouldn't work. That really shouldn't work. And in case you're wondering, Yes, these engines do fire, and yes, they take their fuel from here. Which, that's just crazy pants. That is serious crazy pants. And it's also very nice because you get an engine at the other end when you're in orbit. My current issue is my otherwise very cleverly designed, well, I think they're very cleverly designed craft. They use these for the very high delta V. But the very low thrust means when you're going from the orbit of Kerbin to the moon, you have these burns which are like 3 minutes long. And I actually find very often that something to do with the, I don't know what the issue is. The issue is with my my node following script that I tend to use. Is that like a 3 minute burn, 180 odd seconds needs about 6 to 7 seconds more at the end. Whereas with this high thrust thing, because its total thrust is thrust 600, newton, 600 kilonewtons. That'll get you to the, that's a really nice quick burn, and that means that my node follow script works just fine. So there you go. It's a very wacky way of making an engine. I could put more engines on this if I wanted to. There's probably room for another 8 around the side. Maybe. That's taken my delta V down, but that's still probably enough to get me to the moon. And it's given me a lovely big thrust to weight ratio. So that is a slightly mental rocket building technique which you may be interested in. So anyway, that's enough of that. I could show you. I don't think I'm going to do a video of it taking this whole thing to the moon, because that's a whole thing. But yeah, completely mad rocket building technique. Lots of little engines can be better than one great big engine, depending on what you're doing. I think certainly if I make any kind of object, and I think I want to use a yellow tank as a booster. Sorry, an orange tank as a booster stage. Maybe I want to use this kind of arrangement. Right, this is me back in my actual career mode. And this is the Pallas VI Grasshopper, which I'm now going to rename to Pallas VII. Because I'm going to make a few adjustments based on issues I've had with Pallas VI. And the big issue I had with Pallas VI is that these burner engines, which actually I kind of like. I like the fact that it gives me RCS control without me having to also bring up monopropellant. And I've got enough delta V on this stage that it's reasonable to use. It's not that I'm not so likely to run out of fuel that that's a terrible idea and I shouldn't do it. But the problem is that they will, unlike if I do grab. I'll grab a normal RCS block and I'll put it next to it. You can see that a normal RCS block has jets all over the place, right? Whereas a Werner engine only has the one. So the normal RCS thrusters can turn, they can go laterally, and they can also go up and down, which is the thing I can't do with a Werner engine. So, what I'm going to do is I'm going to move. If I remember, here we go. Move the panels, the sol panels, off to the side there. And I'm going to slap a Werner engine on top. And for no very good reason at all. I mean, like literally, there's no reason to do this other than aesthetics. I'm going to point it so they're kind of pointing. Oh, that immediately got rid of that. That's slightly irritating. And then just moving them a little bit so that they. There we go. I don't believe that won't have any effect on how it actually operates at all. They're balanced because they're all on the same. They're all on the top, and they're all radially symmetrical. So when I hit H, yeah, because I'm going to be this should mean that I should be able to dock this thing, which I wasn't able to do with my previous version. I wasn't able to dock it because I wasn't able. I'd get myself lined up, but I couldn't then push myself towards. And given that the docking port is on the underneath, these are nice. They're there because they're radially symmetrical. They will be nice and balanced. So I should now be able to dock this thing without using a tug. The other thing, what I'm going to do, I'm going to take this off for a second. Park that over there. Now, as you can see, I've got the this is the CX4181 scripted command control system, which is what I use for KOS scripting. But I'm actually going to put a second module on top, and then put the antenna on top of that. My reason being, well, what this means I now have two control systems on top of this thing. I'm just going to temporarily launch. Demonstrate this. The basic idea is I can now have two control systems looking at the ship, and then this is really for development purposes, so that when I am oh, it's taking ages to come up, because I've got a hover script that kind of goes up and down and then keeps it more or less in the same place, which is cool, right? Right, so I've got the two of them. They're basically eating electrical power, but that's fine. But as you can see, I've got the two of them. Now the main one, list files with the list. Oh, list files. Free space remaining 10K. Okay. Now I can bring up the second one. Right, so I now have these two, and this one, the smaller one, the KR2042, only has a file size of 5K storage. I think there's different there's some other differences. Like the amount of power they draw and The main reason I want to do this is I can run my hover script on the main one, and on the secondary one I can then query things like what way am I going? If I want to have a program that hovers but also controls its horizontal position, or its horizontal speed, I'm going to want to do things like when I'm hovering, I want to check, it's drifting along the landscape. I want to find what direction are you moving in? How fast are you moving? And more importantly, how fast are you moving in the axis of the ship? Because if the numbers are going to be different, if the ship's pointing that way and it's drifting that way, or if it's pointing that way and it's drifting that way, and I'm going to want to query that and draw arrows on the screen and other such things. And that's going to be useful from a development point of view, being able to do that and thus keep track of two sets of variables at the same time. I mean, eventually it will all go into one script. The aim is to make a lander that can go from one point on the moon to another point on the moon, given the latitude and longitude coordinates. I can just say, start here, go here, and it'll just go there. I'll want it so that it'll land at a particular speed and remain rock steady and not drift from side to side. For my landing script, I want it to be able to start, come down, look for a flat area within a certain distance, and then hover over to that and land and stuff like that. But with only one processor, that's actually really difficult to do, because you can only have one program running at a time on one processor. Which so if I want to do that I have to do it all in one script, and that's a real pain, and be quite nice to have two. Right, we're going to go back to the VAB, because there's another thing that I've forgotten, which is that the game crashed. Oh, never mind. Oh well, I think we'll just stop it there then. I was just going to put some more lights on, but never mind. So there you go. That's two things. I was looking at a strange engine configuration and alterations to my Pallas Grasshopper lander. And so probably the next thing is I'm going to have Pallas VII on the moon. I'm going to try and get some more contracts done. So anyway, if you'd like watching me play the game up until the game crashes, then hit like and subscribe. I'm part of Nearly Enough Dice, which is a role-playing game themed podcast and blog, and we do other things as well. So nearlyenoughdice.com is our main website. We're also on Twitter and YouTube and various other places, so just search us around there. And finally, until the game crashes, reach for the stars.